It's quite an honor to be affiliated with such a group of people telling truth about what happened on September 11th. Many of us have been at this job for about, 11 years now. I started on day one looking at the evidence because I knew it was a fake from the very minutes that it began. Oh, some of you, I think, took a little bit longer to get a handle on it. From a pilot's standpoint, I knew it was impossible that these aircraft could operate in the positive controlled airspace of the United States of America for more than an hour in some cases without any interception whatsoever. Some of the other things that were clues were as the time came along where we got to the Pentagon attack, which is what I focused on the most. It was painfully clear from the very onset of the video footage that there was no wreckage present at the Pentagon. The lawn was pristine. You could have gone out and played golf with that lawn without hitting any debris. With the exception being closer to the helipad, there were small pieces that didn't look like aircraft wreckage. And we'll get to that deeper into what I'm going to talk about. I had prepared a nice 40-minute presentation that was in PDF format that would have been on the screen, but I talked to Jim this morning and I said, I'm not going to do this to these people. I'm not going to beat them with a fish, just like they've been beaten over and over again with all this stuff where they've seen the same footage of the same scene over and over, because what I've got to add to it can be done without using a pointer. So I'm not going to throw that same stuff up there over and over again. You've seen enough of it. Many of you have been looking at this evidence for years, just like I have. You know what you were looking at. But when we start to talk about the Pentagon attack, there are many aspects of that attack that really didn't work for me. And because I'm a flight data recorder engineer with a lot of experience in downloading the data and what the data looks like, doing power testing, by my curiosity, I became affiliated with a group of pilots that were doing research looking at the contents of what the National Transportation and Safety Board had put out about what this aircraft that attacked the Pentagon had done. Within minutes after I downloaded that file from the NTSB, the government website, I didn't get it from another person, so the custody chain was not broken. I was looking at a file that the government had allegedly created based on what came out of the crash-protected memory of the flight data recorder that was on Flight 77. The first thing that I saw that was the most striking evidence of fraud, that this evidence was created and it was not real, there are two data fields in the very front end of the file for the flight data recorder where it writes the crash-protected memory data into the memory module that's inside of what's called a PIG, or protected memory, the encapsulation. I saw that the aircraft identification number and the fleet identification number were 00000 for both of the data fields. Now let me tell you a little bit about the reason why this cannot be. The flight data recorder's internal circuitry writes this data to the crash-protected memory module on its first initialization when it's booted up for the very first time, when it comes alive after when it's been assembled at the factory. The data in read-only memory within the flight data recorder is provided by the FAA, and it's routed to the flight data recorder manufacturer. This data is the most essential data, probably second only to the data stream that's stored inside the memory, for the following reason. It is the only linkage of the aircraft to that memory module that provides us proof that this information that's stored inside the memory came from a specific airplane. Because we could conceivably, in reality, have two aircrafts have a mid-air collision, both of them 757s, both of them within probably 2 or 3 production items on the Boeing production line together, and without this data, you'd have no idea which flight data recorder module came from which airplane, because they would both be coming from model XYZ model recorder, And without some way of linking that file, you have no idea where it came from. Now let me tell you a little bit more about this file. This data that gets written to this memory module, it's up on each bootstrap, which when you turn on the aircraft's power, which is the power bus called the essential power bus or essential bus, the flight data recorder bootstraps and comes alive. It does power on self checks. It looks at memory, looks at validity of the memory structure within the crash protected memory module itself. If there's a failure in any parameter data in that preamble, which I'm talking about, the aircraft identification and the fleet ID, in other words, the comparison between that data that's written and the data that's in read-only memory, which is non-volatile RAM in this unit, it will send to the cockpit a warning that says FDR fail. Any discrepancy of this nature means that this airplane is not going anywhere. It's illegal to fly a Part 23 aircraft with a failed flight data recorder for the following reason. The aircraft could have an incident. There'd be no way of reconstructing what happened to this aircraft. So this is very important information that was missing. Now, I'll get deeper into what I saw that day when I got to look at this file a little bit closer. As you might imagine, being that I'm familiar with flight data recorders and how they operate, because I test them under a number of different regimens and standards, the primary one, which is DO 160, which is what we test flight equipment on airplanes by. We do power testing under MIL Standard 704 on some military hardware, but basically some of those protocols are built into DO 160 for civilian aircraft. Anyway, going back to this data within the file, one of the more striking things that I found when I did the analysis is that the bootstrapping sequence inside this entire 24-hour data record was incorrect. And the reason why I'm saying incorrect is that when every airplane starts up at the terminal, for whatever reason, power is applied to the aircraft. Cockpit crew comes in, applies power to the primary bus, which is the essential bus. The flight data recorder bootstraps, comes alive, does power on self-test, maintains that it's valid, and it knows it's alive, no errors. Let's say you're not going to fly the airplane, you're just going to do some maintenance on it. You don't really care whether the thing works or not. You may not even look at any of this stuff in the cockpit. But the data recorder is recording data. Doesn't matter whether it's going to go on a flight or it's going to be pushed to the other side of the airport. Airplane's got power on it. The flight data recorder is recording. What I saw in this data is that the normal sequence of engine 1 start, power bus pull down, bootstrapping that has to happen because the bus decays below 70 volts, where the unit will no longer operate and restarts again when the bus recovers. These power on sequences were not there, and there were too many of them. So I saw this immediately and I thought, this data did not come from an operating flight data recorder in an operating Part 23 airplane installed on an aircraft. It came from a bench unit. The reason why I know it came from a bench unit, or it had been on a bench unit, at least the data that was in the crash protected memory that I was looking at, that I was examining, came from a bench unit, is a bench unit does not have aircraft identification in it, for good reason. It's not going on an airplane. So, aircraft ID is 00000. Fleet identification, which ties it to the air carrier that it's flying by, is also 00000. Inside what's called the bit error map of the flight data recorder of a bench unit that's not going to be for flight, this unit knows to bit error mask those two parameter fields so it does not fail the unit for testing purposes. So if I want to run that thing all day long and perform tests on it because I'm checking out its capabilities, it's not going to be constantly telling me that it's not valid, that it's not operational because this data is not there. So the bit error map says ignore these two data fields because they're going to be zeros for good reason. So going back to this data module that I examined, I started to look at the data a little bit more after I informed the person that clued me in on how to find it and how to download it that it was obviously fraudulent and it was not reality, which of course generated the requisite question, how do you know this? Well, then I have to do this very technical explanation about why I know these things, because I work on flight data recorders. To the layperson, they wouldn't know a flight data recorder from a toaster, and that's for obvious reason. You don't need to know any of these things, but you want to hope that that thing is working on any airplane that you're flying on, and you hope you're not going to be a victim of a crash. But back to the flight data recorder's importance, on September 11th, Flight 77's flight data recorder is very important because it was the only forensic data that we had from any of these four involved airplanes. And if you're not aware of the fact that the government asserts that none of the flight data recorders for the other three aircraft were recovered, we'll get into that maybe at the very end of my speech. The absurdity of that is it's beaten way off the scale, but anyway, we only had one flight data recorder record to analyze, and that was Flight 77, so it was probably the most important record that we had that the government had produced, and it was clearly a fraud. Some of the pilots from Pilots for 9/11 Truth had done analysis of this file before I had seen it, and they had looked at the NTSB recreation based on the data that was recovered from this file. And the NTSB had produced a very comprehensive computer graphic showing all the cockpit instrumentation and the external environment outside the aircraft. They also generated a thing called a comma-separated variable file. That was a derivative of what was in the memory of this module. These two files obviously were not one and the same. Now, you might wonder why I would know that. Well, when we looked at the two products, the recreation of the flight based on the data in the memory module and the comma-separated variable file, we saw discrepancies between them. Well, the question comes, how can this be? One is a derivative of the other. It cannot be like that. If there's a discrepancy, it means that one product is clearly not correct and the other one may possibly be, but they could both be incorrect. But it was a glaring issue because if I create an object out of an original I take one thing and I create two objects from it, there should be some way that you can tell that what I made came from the original object in the first place, especially a data object like the flight data recorder file. So this data recorder data, as we looked through the evidence that they provided to us, was not tracking what the NTSB told us that the aircraft's final moments were on that fateful morning. And they did deviate in such massive ways that the first question that we had for the National Transportation and Safety Board is, how can you, with a straight face, tell it that the file came from the crash-protected memory when your creation that you generated based on this file doesn't even track this data? The gentleman, Mr. Ritter from the National Transportation and Safety Board, had really no comment when we contacted him about that, and he was unable to speak to us about why these things did not match each other, which is quite odd because he's at the National Transportation and Safety Board. He should know why they don't match each other. Throughout the course of further investigation, looking deeper into this file, we saw many discrepancies in it, and I want to talk to you about the most glaring ones. One of the first discrepancies that we saw, and for a person that's not an aviator, that doesn't fly in the positive controlled airspace of the United States of America, you would be unable to notice these things. But as a professional pilot, I saw them immediately. As an airliner climbs through flight level 180, which is 18,000 feet to a layperson, the aircraft's cockpit crew members, the pilot and first officer, set their altimeters to a barometric pressure reference of 29.92. This is very important for vertical separation in the positive controlled airspace for a number of reasons. First, you're going very, very fast. You want to make sure that everybody's operating with the same exact barometric pressure reference in their altimetry for that reason alone. So on the way up through flight level 180, both cockpit crew members dutifully will turn they have independent altimeters on each side of the cockpit. You want to make sure that those both say 29.992 inside of what's called a Colesman window, which is a barometric pressure reference. So that's done, and the airplane continues to do its business, climbs up to its cruise altitude. We saw this present in the recreation that they gave us, the graphic representation of what they said the airplane did, and we saw this in the comma-separated variable data. We looked at the flight a little bit deeper into its climb to cruise altitude and all the way to the turn over West Virginia, which is where the aircraft did a course change. We saw some interesting things in this data. The government asserted that during the cruise phase of this operation of the aircraft, that this aircraft was hijacked in a period of 3 minutes. You might ask yourself how you would take an airplane over in 3 minutes' time. The two cockpit crew members are very physically capable men. The guys are wielding box cutters. They're not going up there with a shotgun or a pistol. So if they put up any kind of a fight, it's almost ridiculous that the aircraft could be taken over in 3 minutes' time. But it was done on 9/11, which is very unusual. We have no proof that this occurred, and I'm going to tell you why we know that it never happened. You're sitting in the cockpit of an airliner that's being flown by the flight management system, also known as the autopilot. The reasons for this is that at these flight regimes, any type of a significant upset of the aircraft at this flight altitude could cause sudden loss of control of the airplane. The airplane's cruise speed versus the stall speed, where it can really be out of control, we call it coffin corner, pilot's term. It's a very narrow margin on some aircraft on certain days based on how they're loaded. Sometimes this differential between cruise speed and the speed decay that you have to suffer to be in an out of control situation can be as low as 8 to 10 knots. So you want the airplane to fly itself. You don't want to be hand flying it there unless there's a real reason to do so. During the hijacking, we saw that the autopilot never disengaged on this aircraft. Well, the significance of this is quite striking, and the reason why is that you have a man cutting your head off with a box cutter. At the very least, you would probably touch the control yoke or you would kick the rudder pedals during this episode because you're fighting for your very life. None of these things happen because the minute you touch the yoke or you touch those rudder pedals, the autopilot disengages. At the same time this happens, there's an autopilot warning. It's a loud blip, blip. It comes out over the speaker audio. And blip, blip, it just keeps doing this, that you've disengaged the autopilot. You could now be out of control very shortly if you don't engage it or take hand control. This never took place that day. So we had hijackers that got into the cockpit, got these two guys out of their seats in 3 minutes. Is it possible with the box cutter that you could disable two crew members in 3 minutes? I don't really think that's possible. But what they did when they got into the cockpit is they magically got into the cockpit without opening the cockpit door. The reason why we know that the cockpit door was not open is that switch that's on the cockpit door frame reports that signal to a thing called the Digital Flight Data Acquisition Unit that reports to the data recorder. This signal never toggled. The door never opened. So the cockpit crew was killed by guys that could slide underneath the door. That's pretty amazing, I thought. They must have gone on a hell of a diet to get underneath that slot. It gets better. Not that they got these guys out of their seats in 3 minutes and didn't disengage the autopilot. They get all the way out over West Virginia, over a place called the Radar Hole. You might have heard of it. It's not like a little bar down the street. It's a place where in about 1998 there was no radar coverage. But when they put this data out that there was a radar hole, they forgot to check with NORAD, because NORAD installed what's called an FPS-117 long-range three-dimensional air search radar, which means it projects a stacked beam of energy where the radar itself can determine the altitude of any aircraft flying within 200 miles of it. So when they lost radar contact, and I'll get into that in a little bit because I'm a little bit ahead of myself here with that, this allegedly, that shouldn't have been there, radar hole, allowed them to lose radar contact with this target, and then the airplane did a course reversal. Well, you might wonder, after these guys got in the cockpit, how they would know where they were. Well, it's not very easy, and I can assure you that an airplane of this sophistication, that the mere reprogramming of the flight management system to allow them to see the requisite data on those two screens in the cockpit, which provide all the navigational information for them to navigate the airplane, would take at least 15 minutes for these guys if they knew what they were doing. And the reason why I'm telling you it would have taken that long is in 1995, an American Airlines jet, almost identical to this one, crashed near Cali, Colombia. The cockpit crew was setting the airplane up on a night approach. They were told by air traffic control going into Cali to go to a fix that they were not familiar with. Plus, it was late at night and they were a little tired. They inadvertently, because of their lack of familiarity with the FMS, or the flight management system, punched in the wrong navigation fix. Subsequent to that mistake, these pilots lost their lives along with everybody on the airplane but one small infant that survived the crash. And this airplane is very important, by the way. We're going to talk about it later. So we know that the flight management system is so complicated that these guys that couldn't control a Cessna 172 during a check ride were able to sit in that cockpit and immediately know where they were at and reprogram the flight management system so they could navigate back to the place they came from. And this is problematic for them because this airplane, when it did the departure, the normal procedures, air traffic control will radar vector the aircraft out of the area. These radar vectors are complex. There can be very many course changes as you're vectored out of the airspace that you're leaving before you get to go on course to your destination. The cockpit crew, these two hijackers now, had no possible way of knowing where this aircraft was. They couldn't have reprogrammed the flight management system because I would see that in the data that's in the flight data recorder. There's no evidence of them reprogramming anything. They instantaneously knew where this airplane was. They did such a good job of knowing this that they dialed up on the autopilot a reciprocal course that would allegedly take them back to exactly where they came from, but it doesn't really work like that. The aircraft executed what's known as a standard rate turn. And the reason why we call it a standard rate is that in 2 minutes' time, this aircraft will transition 360 degrees as it does the course reversal. We want a nice leisurely turn, so all you folks that are sitting in the back of this airplane aren't going to be pinned to the bulkheads with your lips pressed up against the windows. Because if we do that to you 3 or more times, you're not going to want to fly with us anymore. So that's the primary reason. We do nice gentle turns so you don't get airsick and want to kill us later when we're landing. This airplane executed a standard rate turn and then did this course reversal back to where it was going to go attack the Pentagon. But when it did this over this radar hole where radar contact was lost, it caused a number of problems to happen all at this point in time. And we're going to talk about aircraft identification protocols by air traffic control right now. When a target is lost on radar, and in this case, these guys, it took a long time for them to finally decide they're going to turn off the air traffic control transponder on board the plane. What the transponder is a unit that tells the radar facilities on the ground who you are. Because the radar doesn't know who you are, it has no clue. It's also known as what's called secondary radar. Primary radar is the main beam of the primary antenna striking your aircraft and the beam reflecting off the airplane. It provides a blip merely. Well, air traffic control doesn't know what that is. The only way they know what that is when they talk to the pilot on the radio, and he says, "Good morning, Atlanta Center. This is November 549 Alpha Alpha. We're out of flight level 320 for 350. And the controller says, "I want you to squawk 4735. And the pilot will dial up this number in the transponder, and the data block appears on the radar scope, which is doing what's called secondary radar. Now they have a data block. They will now have your flight number because you told them, a regular aircraft that I would fly as a general aviation plane won't have a flight number such as American 77, for instance, because it's not a scheduled air carrier. So they will have in the data block, once the pilot checks in as American 77, not by its end number like I will in another a smaller aircraft type that I sometimes fly. They will put in the data for your flight number because they don't know who that is. The controller has a flight data strip sitting in front of him that's produced by a printer that comes out of the console. So he knows you're coming before you arrive there, but he can't put you into his sector until he sees you identified positively. He'll give you a new code. That code changes as you transition this airspace, by the way. It doesn't remain the same. So these cockpit guys, the hijackers, turned off the transponder after several minutes. They decided, well, we'll leave it on, and then they go out over this radar hole where they were lost contact on radar. So nobody had seen them on radar any longer. They disappeared for many miles over a place where an operational, long-range, 200-mile radar existed. As far as we know, there's no evidence that proves that this long-range 3D air search radar that didn't even need to know the data from your aircraft itself at what altitude you were was operational on 9/11. It was not disabled. In its what we call reduced capability mode, or red cap mode, it could still see out 80 miles when it's not in final driver. But we lost radar contact with that airplane out there. The plane did this course reversal that it should have never done because hijackers would have no reason to care about your physical safety back there being pressed up against the bulkheads because they're going to kill you in a few minutes. They don't care if you get airsick. They're not going to execute a nice leisurely standard rate turn so you don't get pissed off because you're not flying with this airline anymore after this flight. But this turn occurred, and that was really kind of puzzling because these guys wouldn't have had any idea that, first off, how to execute a standard rate turn in the first place, and they'd have no constructive reason to do it. How to execute a standard rate turn in the first place, and they'd have no constructive reason to do it. Now, the plane is inbound over West Virginia, and it finally comes back up on radar again, in a place where it should have always been on radar, continually on radar. Air traffic control assigned Flight 77 to that target. Normal protocols prohibit this assumption that the airplane is the same aircraft. Any airplane could have popped up in that airspace, and you don't know who he is because you can't see him. If you don't have radar contact with the guy in that cockpit, you don't know who he is. But immediately, air traffic control assigned that very same flight number to an airplane they had no radio contact with, nor did they have a radar reply for several miles. And that's against all known FAA protocols for air traffic control. It's never done for a reason. So now we have this plane coming back inbound. It's called Flight 77, but how do we know it? We can't see anyone. Their pristine passport hasn't landed on the street yet. And it comes inbound, and everybody declares it's Flight 77. But we now have a problem with this airplane because a radar controller named Danielle O'Brien has been watching this on her screen. Danielle knows that this airplane is maneuvering very, very rapidly, and it seems to be going a lot faster because now it's on radar and they can track the speed. She thinks it's a military airplane based on her comments to the press because it's way too maneuverable for an airliner. It's going way too fast. This airplane continues inbound based on the record that we saw in the flight data recorder, and it's been relabeled as Flight 77 when nobody knows for sure that that's really the aircraft that it is. And an air traffic controller thinks it's a military target based on its maneuverability and its speed. The airplane gets closer to the Pentagon, and you've all heard the infamous Norman Mineta conversation in the PIOC with the Navy's adjutant in front of another gentleman named Marty Felger, who is second in command of the Federal Aviation Administration. And the comment is, does the order still stand? And you're all familiar with that, so I won't bore you with it. So anyway, this unknown aircraft is coming back inbound towards Washington, D.C., which is what's called Class Bravo airspace. And I want to tell you about Class Bravo airspace a little bit because it's very important you know about it. You don't barrel into Class Bravo restricted airspace anywhere without radio contact with people in the facility. And that we've already ascertained that we have no contact with this airplane on the radio because the hijackers have no reason to talk to air traffic control. They don't need a clearance. They're hijackers. They're barreling right into Washington, D.C. Their potential targets could be the White House. They could be hitting any number of high-value targets in the Washington, D.C. area. The airplane begins to descend, and these controllers are watching this happening. And there's some discussions with air traffic control in Boston, who's going to possibly provide intercept capability for this aircraft to go take a look at it at the very least. But they've been watching it now for quite a long time. The thing that was so important in this data that I was looking at in the flight data recorder is some of this data was very strongly indicative of the fact that it was fabricated because as these pilots maneuvered this airplane, turned it gently and stuff like that, their feet never touched the rudder pedals. So they lost their legs probably, or they had their legs strapped together, or maybe they were in a three-man, or the things with the legs strapped together. They couldn't use rudder pedals for some reason. But not once during this whole return back to the D.C. area were rudder pedals used. I saw that from the time that the aircraft had climbed out in the flight data record that on the initial takeoff, because of the compensation for thrust, the pilots in the cockpit, whoever they were that were really flying this thing on the takeoff, used rudders to compensate for the thrust-related yaw that occurs during takeoff. In other words, they had to stand on the right rudder to keep the airplane going straight when it climbed. After the cockpit was taken over in this magical 3 minutes, where the cockpit door was never opened back earlier in the flight, for several miles, for hundreds of miles, those rudders weren't touched again. And we know this from the NTSB recreation and the comma-separated variable file that we looked at. For the most part, those agreed. But there were some small discrepancies even in some of the data stream, and we'll talk about that maybe a little bit. So this airplane was unidentified. It continues towards Washington, D.C. without a clearance into Class Bravo airspace. Washington, D.C. airspace is heavily protected. It has multiple military facilities with fighter capability. Anyone penetrating the Class Bravo airspace at the bare minimum on a day like 9/11 would have been intercepted because they could not afford for an airplane weighing approximately 100 tons with known or assumed hijackers on board to penetrate that airspace because they could hit any number of targets that you don't want them to get to. Now, people wonder about the action that would have been taken had an interceptor gone up there to take a look at them. Well, let's put it this way. I've been intercepted before in an airplane. You have two aircraft approach. One comes up on your wing and the other guy circles. The guy on your wing slows down and he starts initiating hand signals saying, land, here. And you do what he says and you follow him, because as a pilot, you know what the intercept procedures are and how to follow him. He will lead you to the runway that he wants you to land on. No interceptions took place that day, so these guys get into the Class Bravo airspace. And inside Class Bravo airspace, which they should have been escorted into by interceptors by this time, which never arrived because they were out over the ocean going in circles because air traffic control told them to just tool around out there. These guys got closer and closer, and the distance was called out by this Navy adjutant that was talking to Norman Mineta, saying the distance is now 40 miles. Does the order still stand? Talking to Richard B. Cheney. The plane gets closer to what's called prohibited airspace. This is the airspace around the White House and the Pentagon. There's an air defense system inside Washington, D.C. to protect high-value targets. Basic Point Defense Missile System. These are pop-up launchers with radar systems that pop up out of rooftops, lock on within seconds, and fire a missile and take an airplane out. Well, you might wonder, would they take a commercial airplane out that's approaching Washington, D.C. in this fashion? You bet they would. Because the buildings down there are much more valuable for a number of military reasons. They're strategic targets now. They're no longer just a building. So they always had the authority, both the interceptor pilots, for a number of years, to make the decision to take this airplane down when they go intercept and it doesn't follow instructions. But it never was a problem to make the decision because no interceptors were allowed to get anywhere near this aircraft. The plane keeps barreling closer and closer into Washington, D.C. No missiles are fired at it. It goes right by the White House at a distance where Secret Service agents on the roof, armed with Stinger anti-aircraft missiles, over-the-shoulder anti-aircraft missiles, would have been able to shoot this airplane down without any problem from their position. They were either told not to shoot at it or were not on the roof at all. I'll tell you from personal experience flying over Washington, D.C., it's unprecedented that the Secret Service wouldn't have been on that rooftop that day with Stinger missiles on its shoulders. And the airplane would have been down because it would have got shot down by 2 or 3, if not 4 Stingers. Then this airplane finally strikes the Pentagon and everybody knows that the flight's over. So now we're going to go back and talk about the flight data recorder because I've neglected it for quite a bit. We looked at the flight data recorder record for this aircraft, and there were a number of things that were wrong with it. Many of you have seen the photographs of the light poles on the approach to the building. These poles are a trajectory record of the airplane, or what struck the Pentagon. And the reason why I say that is that we know where the center line of the fuselage had to be to strike 6 poles on the way to the building. And we also know what the minimum wingspan of the vehicle would have to be, the air vehicle would have to be to hit all of these poles and remain on course and strike the building where it hit it. This data inside the flight data recorder did not match this trajectory. It was quite off, both in altitude and azimuth. And we got no explanation from the National Transportation and Safety Board why their flight track that they depicted on their recreation based on this data from the flight data recorder did not match the data that we had from the poles. Well, a lot of people surmise that these poles were sheared and planted. Well, I pointed out in the thing that I provided to Jim Fetzer that got published on Veterans Today that this trajectory record, I believe, is real because I don't know anybody that can take a sheared off pole and javelin through it through a taxi cab window and almost hit the taxi cab driver. So I believe those poles were sheared by something, and I'll get to that in a minute. So we have two different flight paths. We have what the flight data recorder says is 62.5 degrees approaching the building, and we have these struck poles that are sheared off at a declination angle that tells us that there was a certain trajectory to the building that we could see in the evidence of the poles themselves. And now we get to this infamous final part of the flight where we see 5 frames of video provided to us by our wonderful folks at the Federal Bureau of Investigation. In this video, ladies and gentlemen, you saw an object enter the screen on the right-hand side, and if I had it up on the screen, I could show you with the pointer where that was, but you've all seen it probably. And that shape is not a Boeing 757. And if you'll note, the altitude of that aircraft is no less than probably maximum 7 or 8 feet above the ground. Boeing 757 cannot fly at an altitude of 7 feet above the ground. The reason why this is not possible for a Boeing 757 to fly in this region, there's a phenomenon called ground effect. Yes, thank you, Barbara. Anyway, ground effect is a place where the aircraft does not want to descend further because it's lost a whole lot of drag because the wingtip vortices that are generated on the wingtips, those are not manifested anymore. They've gone away. All that drag has left. On this airplane that day, which was flying at a speed that we know of 465 knots, after it executed a 330-degree turn on its approach to the Pentagon at a very high rate of speed, 4,400 feet per minute descent rate, which is also a little bit ludicrous, the aircraft was able to level out and fly at this absurd altitude. Well, it can't happen strictly because ground effect would not allow the airplane to descend. The pilot would have had to command almost full forward pitch down from the yoke to get that airplane to go lower than probably 20 feet above the ground for a number of reasons based on this ground effect phenomena. It couldn't occur because the plane would want to climb at 465 knots. Oh, I better wrap this up real quick. Anyway, I went a little bit long in some of this discussion about why these things couldn't possibly be. But based on the flight data recorder data that I saw, a lot of things didn't line up. The final trajectory didn't line up. The rudder pedal is not being used to execute this nice 330-degree turn. Very important at this phase of the flight as it turned to strike the Pentagon that it saw from at least 40, 50 miles out with no problem. The turn was executed without the use of rudder pedals, and the airplane maintained what's called coordinated flight. Coordinated flight occurs when an airplane is not slipping or skidding because the rudders are used to compensate for anomalies and G-forces as the plane is turning at a high rate of bank angle as it turns. And we hadn't seen any of the rudder deflection since the captain had used it on the takeoff. What I wanted to state for the record and make you all aware of is the fact that we saw discrepancy after discrepancy after discrepancy in this record, and our questions to the NTSB were not answered. We asked them time after time, how can this be? How could the flight data record end 380 feet above the building without striking the building? How can this data record end inside the outer wall of the building? How can it not match the trajectory of these light poles that the aircraft allegedly struck? And we got a number of answers that didn't work. And we also know that the impossibility of flying this airplane at such an impossibly high rate of speed, beyond 350 knots in straight and level flight, in some cases is absurd that it could even achieve these speeds without experiencing what's called an accelerated stall, where the pilot loses control and the airplane hits the ground prematurely. So we've lost control of an airplane many, many times on this flight that in reality, based on the way the data doesn't work, and we have inexperienced crew members flying the aircraft that couldn't possibly have controlled it with such precision. They're allowed to penetrate Class Bravo airspace and in prohibited airspace without a clearance, without two-way air traffic control clearances at all, and in all reality, they would have been shot down. But going back to the beginning of this whole thing, when we examined the flight data recorder, we knew that one thing that didn't work was that this recorder should have also been another model. And the model would have been a tape-based unit instead of a solid-state memory module unit that was recovered at this crash site. I'm running out of time. In the closure here, there were too many discrepancies about Flight 77, just like all these other discrepancies with the other two flights. The plane could not have done these things. It couldn't have been flown by these hijackers in this fashion. And then the NTSB's falsification of the data is obvious, and they forgot for whatever reason that when they erased the crash-protected memory module that they should have replaced the data for the aircraft ID and the fleet ID number that was missing that invalidated the whole entire thing. I would compel you to go to Veterans Today and look at an article that was presented by Mr. Jim Fetzer called "The Official Story of the Pentagon Attack is a Fantasy." And it's a much more comprehensive dissertation than what I gave you here in this very brief talk.